Hello everyone, my name is Anis with CyneWorX Technologies and you are watching my YouTube channel. Today I'm going to talk about static routing. So what static routing is, I assume that you already know what routing protocol does. So the purpose of this lab is we need to configure like different networks, and we are going to ask the router to go to a specific route if you need to go to if you need to communicate with those devices. Okay, so first of all, I'm going to explain the diagram I have right now. I have three different networks. On this network on my left hand side is network 10. Okay, and this is the network 1. This is the internal network of router 1, and this is the layer 4, or you can say layer 3 or layer 4 network, okay, between these two routers. And then this is router 2. Router 2 has network 11 internal. Okay, so I have three PCs on both sides, and this is the interface, the internal interface of the router, and I'm going to assign this IP address 192.168.10.1/24, and then it's going to be 10.2, and this one is going to be 10.3, and this PC is going to be 10.4/24. Okay, so this is going to be my local area network, and then I have another LAN on my right hand side connected to router 2. So 11.11 network IP address is 192.168.11.1 on the interface of this router 2, and then PC is 11.2, 11.3, and 11.4. Okay, and now I have this network 11.1 is 192.168.1.1 is 000. Interface on router 1 and router 2 interface 000 has this IP address. Okay, so first of all, I have already configured these routers, so I'm gonna remove the configuration. So let's see. Okay, so let's do show one. Okay, I have this host name, then I have this IP address is assigned. Okay, this IP address, and so I'm gonna do write erase, okay, and confirm, and I'm gonna reload. All right, so router 1 configuration has been removed. This is how you can remove configuration of your router, but you have to be very careful. If you are working in a production environment, you should really know what activity you're going, otherwise you're gonna lose network and all your configuration. Okay, so I'm gonna do the same thing, write erase, okay, confirm and enter, and then reload. Okay, in the meantime, what I'm gonna do, we just want to verify. I have already assigned the IP addresses to these PCs. If you don't know how to assign the IP address in the packet parser, I'll show you. Just go to click on the PC, go to the IP configuration. Okay, and then if you have configured DHCP on your router or switch, layer 3 switch, then you can use this option. Otherwise, you have to choose static. Okay, so like for example, this is the IP address 10.2. I have enter the 10.2 IP address, then subnet mask, and then the default gateway. Okay, so since this one has a valid IP address, that's how I did it to all these PC. Okay, so .3, .4, these three devices are in the same network. So even though my routers are down, but at least my local area network should be able to communicate to each other. So I'm gonna ping my local IP address 192.168.10.3, because I'm on PC1, so PC1 has IP address of 10.2, and This PC is of, this IP address is of PC2, like the one in the middle. Okay, it's pinging, and I'm gonna verify the next IP address, which is 10.4. All right, so we have successful communication between these PCs. Okay, and now let me try, I'm gonna try 11.3 and 11.4 from this PC, which is 11.2. And I showed you guys how to assign the IP address. There's just go to the PC and then click on IP configuration, or you guys can go to the config, then the fast Ethernet like this, and then you can assign the IP address here. Okay, so I have already assigned the IP address. If you don't know the IP address, there's a IP config command, and here's the IP address of this PC. Okay, and this is the MAC address, subnet mask, and the default route. Okay, so I'm gonna ping 192.168.11 dot. It's either, okay, I'm gonna ping 3 and then 4. So I want to make sure we have a successful communication between all the devices. Okay, right, so this one is pinging. Now I'm gonna ping this PC in network 11. So okay, the story for right now is, as of now, we are able to make these devices work, and they are able to ping each other. The same situation here in network 11, that all these 3 PCs, they are working as expected. So they are connected to the network, but internal network, only through this switch. So there is no, like, this LAN is down, this is also down, and this line between the 2 routers, this is also down. So now we have to configure the router, and according to the diagram, to this interface 0/0/1, we are going to assign this IP address 10.1, because this is our internal network, local area network. And this IP address is going to be 192.168.1.1. This is network 1. So I have assigned this IP address 192.168.1.1 to this interface on our layer 3 network connected to another router. And the other side of this network, it should be 1.2. It can be anything in /24, but I just give it 1 and 2 to, it's easy to remember in packet tracer. Okay, so now let's go to this PC, this router first. Okay, as usual, you said no. Okay, enter, and we go to the config mode. First of all, we need to go change the host name. Okay, R1, and let me show you guys something. So we need to do show IP route, and anytime if you guys are in the config mode and you want to see like a show command, you have to enter do before the show syntax. Okay, so show IP route. Okay, there is no route right now. Okay, and do show IP interface brief. Okay, so all of my interfaces are down and none of them has been configured yet. So I'm gonna go to the interface GI 0/0/1 first. I'm gonna assign that 10 network. Okay, so IP address 192.168.10.1 subnet mask. Okay, and the next command, we need to bring the interface up. So because by default it's admin down, means the interface is shut, so we have to do the no shut, enter the no shut command, so the interface will be up. And as soon as you hit enter, you will see this message confirming that the interface is up now. And now also you can see this link light, it's green, and this side is still amber because it has not established the connection yet. So it will just take a few seconds, and then this will also become green. Okay, and as you guys can see, this link light and this link light between the router, it's still down. Why? Because we have not configured this interface yet. So now I'm going to configure that one. Interface GI0/0/0. Okay, IP address 192.168.1.1 255.255.255.0. Okay, and no shut. Okay, so this interface is up. The next command I'm gonna do, okay, let me show you guys something. Show IP route. So the interface should be up, but the protocol, oops. Okay, so we have only this network in our routing table because this interface is still down. I was supposed to do show IP interface brief. Okay, so as you guys can see, in router, we are in router 1, right? So this interface, this IP address, internal, they are connected to the switch. So this is up and up, okay, because the connection has been established. While here, on interface 0/0/0 with the IP address of 192.168.1.1 connected to this router on the right hand side, like router 2, it's not up. Why? Because well, the status is up because we just run the no shut command on it, and the protocol is down because we have not configured this side of the interface yet. Okay, so now what I'm gonna do, I'm gonna do assign one of the command IP route. So I'm gonna ask, okay, let's do this command later. Sorry. Okay, I'm gonna do end and save. Now let's go to the router 2. We'll be doing the same configuration on this side. So this IP address 192.168.1.2, we have to give this IP address to interface 0/0/0 and 0/0/1 should be given this IP address 11.1. Okay, these are two different networks. So let's go enable config key host name, host name R2 CyneWorX. Okay, and interface 0/0/0. Okay, and the IP address 192.168.1.2, because the other side is 1.1, and this router on the interface 0/0/0 has to be a different IP address than the one on the other side. 255.0 no shut. Okay, as soon as you hit enter, now see this interface is up. So now if I do show IP interface brief, it will be up and up. Okay, 0/0/0 is up with the IP address, and okay is yes, and method is manual because we assign this IP address manually. Status is up and protocol is up also, so it means everything is good. Now interface, this one is still down and no IP address has been assigned. So let's go to this this interface, which is DI0/0/1, and this is our internal network. So we're gonna assign this IP address 192.168.11.1. Okay, subnet mask 0 and no shut. Okay, So end and save. Now let's do show IP route. I'm on router 2. So this router has only 2 networks in the routing table. Okay, this is the routing table. This is where you see like how far your router can go, how far your network can communicate. Okay, so we have 1.0 network, which is this one, and we have 11.0 network, which is the local network. Okay, internal. This router does not have any information about router 10, so we will not be able to communicate between PCs in network 11 will not be able to ping these devices in network 10. So let's try. Okay, so I am on PC 4, like this PC. I am trying to communicate to this PC in network 10, and destination host is not reachable. Okay, and let's try something else. 10.1 is the routing IP, sorry, is the IP address of the router 1, but on the different network. And why it's not communicating, even though all the link lights are green, but this router does not know the information, does not know the any network information connected to the other side of this router unless we configure it. Okay, so we can either use OSPF, EIGRP, or RIP protocol, routing protocol. They're a dynamic routing protocol, or we have to do it manually. So what we're gonna do, I'm gonna ask this router that, hey, if, because we have just a few networks, so we can do that manually. Okay, if we have a lot of network, like let's say we have 200 networks, 200 routers in our network, we will not be able to do that manually. Okay, if we do that, we'll be making a lot of mistakes and there will be like a lot of issues. So the best situation then will be using either OSPF, EIGRP, or RIP, depends on your network design, or depends on your network information from your management. Okay, so since we have only 3 networks, they're easy to configure. Let me go back to the router 1, and okay, I'm going to show you one more time. Was the router 1 has this network in the routing table, 1.0. 1.0 mean anything in /24. It can be like 1.1, 1.10, 1.100, or 200, or until the last IP address. And this one also has the same situation, but this is a different network. So this router has only 2 routes. Okay, so we can communicate between 1.1, 1.200, and 10.12 to 10.200, 10.250 something. Okay, so now we are going to add this network manually. Okay, so we are going to ask the router 1 that, hey, if you have a request to connect to network 11, you have to go through this IP address. This is the next hop IP address, or we have to give the interface number. Okay, so we have 2 interfaces connected. So if we are, because if we send the traffic through this interface, all the traffic will go to router 2, and router 2 already knows about network 1 and network 11, so it should be able to accept the protocol, the data, and send it back to router 1. It will be like, okay, yes, I have this network with me. So let's do config T and the command to So the static route will be IP route, and I'm gonna assign, since we are in router 1, router 1 has information about network 1 and 10 but not network 11. That's why we are gonna be sending this network information to router 1. So let's say 192.168.11.0. The reason we are saying 11.0 is because we are trying to advertise the whole network. 11.0, according to the subnet mask, it should be any IP address between 1 to 254. Okay, so then the subnet mask 255, 255.0, and there are two options now we have. So in router 1, we are asking router 1 that, hey, if you need to go to this address, this network, 192.168.11.1, with this subnet mask, and the next step will be go to this IP address, this specific route, or through this interface. Okay, so let me do a question mark, and you will see a lot of these options, but the one we are going to use with the forwarding router's address, which is in our case, which is 192.168.1.2. Okay, this is the IP address of this router 2. So again, we are asking this router that, hey, if you need to go to this network 11, then you need to go to this IP address. So again, this router already knows about, these two networks in its routing table. So it will add, this information in the routing table also. Okay, so now let's do end and save. And now if we do show IP routes, okay, so before we had network 1 and network 10, they're directly connected, and now we have 192.168.11.0, okay, /24, because we asked this router that, hey, add this route in your routing table, and it's connected through this network 1.2. Okay, so here, as you guys can see, before it was C and L. C is connected and L is local, and S is static. So where is S? Right here. Okay, so if you see any of these code, like for RIP, you will see R. For BGP, you will see B. For OSPF, you will see like different options like E1, E2, or O. Okay, so right now we should be able to communicate from network 10 to network 11. And now let's configure this also. So show IP route, it should have only 2 routes. Okay, as expected, this is only directly connected routes in the routing table. Okay, so I'm gonna do config T and IP route. Okay, 192.168.10.0. Okay, because now we are going to the other side. Like router 1 has information about network 10 and 1 and 11, because we just configured network 11. We advertise network 11 in there statically. Okay, and now we are in router 1, so we are going to add network 10 in the because network 10 is not in its routing table, and these PCs should not be able to communicate. Okay, so 192.168.10.0 and subnet masks. And so what we did here, I'm gonna do question mark again. I'm going to send this information. Okay, I'm gonna ask the router that if you need to go to this IP address or this network, you need to go through this interface. Okay, 0/0 /0 because this is the external interface connected to another router. So again, we are asking the router, say, hey, if you need to go to this network with this subnet mask /24, you have to send all traffic through this interface. Okay, so let's do enter. Okay, and save. Once we save, we should see show IP route. All right, so now we have, so if you guys can go back, we had only router, only 2 networks in this router 2, 11, okay, and 1. 11 network and 1 network. Now we can see 11.0, sorry, 1.0 network, and we can see 10.0 network, and we can see 11.0 network. And so, okay, so here, C, you can see the local connected, but this one is static, okay, because this one is not directly connected. Okay, and we have asked this router to go through this interface. Okay, so now if I ping this IP address from this PC, do you guys think it's gonna work or no? Okay, let me show you something. So ping, I'm gonna ping 192.168.11.2. Okay, I'm gonna give you guys 3 seconds to think about it and answer. Is this gonna ping the IP address, or the destination host will be unreachable? Okay, so 3, 2, 1, and yes, it should ping this IP address, because right now we have all routes in the routing table of both routers. Okay, the first packet will be dropped and it should be successful. No. Okay, it might take some time. So let's do 192.168.11.1, and yes, 1 is working. Why not 2 should be working? Yeah. All right, so sometimes it takes a little while, but it should be working. So we can ping PC, we can ping this PC, and then I have pinged this PC, and now I'm gonna try, actually let me try from this one. Okay, so I'm on this PC right now, and I'm gonna ping this IP address. So ping 192.168.11.2. First packet will be dropped, and then it should be okay. So it's taking some time because the request goes to like one IP address, and then like this request goes to switch, and the switch, from the switch it goes to this, and then the router thinks, okay, what should I send this traffic? And they say, oh yeah, I know, because I know this network is connected through this interface or this IP address. So then it sends it here, and then the router thinks about the network and say, okay, let me see where I have this network, and then in the config it says, oh okay, this network is connected to this interface. Okay, so we have an established connection between all the devices. I'm gonna ping one more IP, like okay, you know what, let me okay, let's do trace route 192.168 11.3. So by this command, what I want to see is, like, I have a successful communication, right? and the connection has been established between this device and this device. So right now I'm on this device 10.4, and I am trying to know like if I can ping 11.3, which is this one. But I'm not just simply pinging, I'm asking the router, I'm asking the PC to find out and show me the exact way, the way which you have taken, the routes you have taken. So show me those routes. Okay, so if you see here, tracing route 192.168.11.3 over a maximum of 3 hops. So this is the first one, 10.1, 192.168, 10.1. That's the first IP address where it goes. So 10.4, this packet goes to this interface of the router 1. Okay, and then the next one is 192.168.1.2. So once this router receives this request, it sends this to router 2, the IP address on /0/0/0/0. Okay, this is the IP address. And the third one is the final destination. Okay, 192.168.11.3. So if we have another router in between here, or like in another router like in the network 11, then we should see all those in the list. Okay, so there was static routing, and I hope you guys enjoyed the video, and please let me know if you have any question, concern, or if you have any recommendation. I would appreciate to leave me a message in the comment section. And if you have not subscribed to my channel, please subscribe. Thank you.